Thank you to everyone who has joined us so far. We still have some folks that are getting in through the waiting room. So if we'll be patient, we'll just get started in just a minute or two. All right, thank you so much for joining us today. I'm just going to give it about 30 more seconds as people are still getting in the waiting room, but I completely respect your time this evening. So just give me about 30 seconds and we'll get started. All right, thank you to everyone for joining us this evening. We are here with the Northeast Ohio Regional Sewer District to talk about our Lower Shaker Lake project. We will be exploring our Lower Shaker Lake Dam recommendations, both past and present. I'm very glad that you're here today. My name is Jen Eltine, and I'm the Senior Manager of Community and Media Relations here at the Northeast Ohio Regional Sewer District. My email address is up there if you do have any questions for me down the road, but I do have other information. I'm going to get us started today with just a little bit of housekeeping information. So for those of you who have maybe very detailed questions or want to do a deep dive or just see some of the images that we're showing you in person, please come to one of our two open houses. Tomorrow, Wednesday, August 20th, we will be at the Cleveland Heights Public Library on Lee Road from both 11 a.m. until 1 p.m. as well as 5 until 7 p.m. This webinar is being recorded and we have lots of other really valuable information up on our sewer district's website at neorsd.org/Lower Lake. If you run into a friend who didn't get a chance to catch this webinar, we will have it posted and we will have that posted sometime tomorrow. As far as questions this evening, if you look at the bottom of your Zoom window, you should see a box that says Q&A. It looks like a little talk bubble with a question mark in it. If you have any questions for our group this evening, please drop them into the Q&A. And there's a group of us that will answer some of the questions within the Q&A function. So those answers will show up on the answer tab. And we will save some of the questions that maybe have a little bit more nuance or need like a very detailed explanation. We will save some of those until the end, and I'll ask our panelists those questions at the end. If you're watching this as a recording, or if you're not familiar or you don't feel comfortable with the Zoom Q&A function, you can also email our customer relations team. We do have somebody online checking those emails this evening, or if a question comes up tomorrow and you really want to ask it, please use our customer relations email address, and it's really easy to remember. It's askus@neorsd.org. And then I would like to introduce you all to our Chief Executive Officer, Kyle Dreyfus-Wells. And she is going to kick off the presentation, give you a little bit of agenda information and a little bit of additional background information. So Kyle, take it away.
Thanks, Jen. Good evening, everyone. I'm Kyle Dreyfus-Wells, CEO of the Northeast Ohio Regional Sewer District. Thanks for joining us tonight to continue the conversation about our revised recommendation for Lower Lake Dam. So earlier this year, we updated our recommendation for the dam to not build an ODNR compliant dam at Lower Lake based on 4 elements, all coming together. And we're going to talk about each of those elements tonight. The sewer district is in this conversation about Lower Lake Dam because we are responsible for implementing the Regional Stormwater Management Program, where we work with our member communities to provide watershed-based solutions to flooding, stream bank erosion, and water quality problems. And for us to participate in a project, it must address those issues. As we have refined modeling in 2025, we understand now that the Lower Lake Dam does not have notable flood control benefits downstream, and we cannot pay for it under the Regional Stormwater Management Program. We can, however, fund the dam removal and stream restoration at Lower Lake, like the work we're planning at Horseshoe Park, as that would improve water quality within the Doane Brook and reestablish a stable stream channel. The change in our recommendation is driven by more information. I know that this is a big deal in terms of the sewer district changing its recommendation, but this is how planning works. You go from master planning through feasibility, pre-design, and design. You learn and you adjust along the way. And we're going to talk about all of that tonight. We recognize that we're at the beginning of this renewed conversation about Lower Lake Dam and the ODNR safety issues there, and we look forward to continuing this with you all tonight and Wednesday as well, and then on into the future. So let's review tonight's agenda. So we are going to just briefly reintroduce the Northeast Ohio Regional Sewer District for folks who may not be familiar with our work. We'll talk a little bit more about the Regional Stormwater Management Program, and then I'll turn it over to Matt Sharver, our Director of Watershed Programs, who will put Lower Lake into context, both in terms of the overall Doan Brook watershed, and he'll give a quick update on the Doan Brook restoration at Horseshoe Park project, which we will kick off next year in 2026. And then Matt will give the updates on from our 2021 Stormwater Master Plan recommendations, the updated information and analysis that we have, talk about our 2025 revised recommendations for Lower Lake Dam, and then give an understanding of some of the cost numbers that we're seeing, and we'll talk about next steps. So just quickly, we are the Northeast Ohio Regional Sewer District. We provide regional sanitary and stormwater management services to the city of Cleveland and 62 municipalities across portions of 4 counties. We're an independent political subdivision of the state of Ohio, governed by a 7-member board of trustees. And this next slide shows our service area. You can see our 363 square mile service area and the communities that make up the Northeast Ohio Regional Sewer District. And you see here are 2 separate utilities that we run. One is the sanitary sewer utility, which you see all those communities in that teal area. That's all the portions that send their wastewater to one of our 3 wastewater treatment plants. But for our conversation tonight, we're talking about those streams, pipes, and culverts that drain more than 300 acres of land and make up the 489 miles of our regional stormwater system. And these are the streams of our region, including Doan Brook, which is the focus of our conversation tonight. So we do our work at the sewer district across 3 program areas, and you can see these here: running the region's 3 wastewater treatment plants, addressing the region's legacy issue of combined sewer overflow with Project Clean Lake, and again, our focus tonight, our regional stormwater management program, helping our member communities address flooding, stream bank erosion, and water quality issues. And just a picture to put us into context of the issues in the Doan Brook watershed. This is flooding on MLK Drive in Rockefeller Park, the Doan Brook coming out of its banks, causing a significant public safety issue. And these are the types of problems that we are responsible for helping the region solve under our regional stormwater management program. And across our service area, we have 1.4 billion in stormwater needs that we are collectively working on solving. So with that, just quick introduction to what we're going to talk about tonight, quick review of the sewer district and our regional stormwater management program. I'll turn it over to my colleague, Matt Sharver, to talk in detail about our updated recommendation. Thanks, everybody.
All right, good evening, all. Thanks again for joining us, and thanks, Kyle, for that summary of this agenda for this evening. And so we're going to spend a better part of a half hour or more moving through a series of slides and graphics to help understand the district's revised recommendation. So whether you're new to the conversation this evening or you've been following us over the last period of a few weeks or so, we're going to give you some more context to what's happening at Lower Shaker Lake. And we're going to start with a little bit of information about the Doan Brook watershed. And then, as Kyle mentioned, I'll provide you an update on the Doan Brook restoration at Horseshoe Park project. So this is an outline of the Doan Brook watershed. That's what you see outlined in black. The Shaker Lakes are located in the upper watershed, and you can see the blue lakes there labeled. And then as we move from right to left across the screen, the middle portion of the watershed contains University Circle, which is a low point in the watershed before it moves Dome Brook through the cultural gardens in the city of Cleveland on out to Lake Erie, the receiving water body. And so we'll zoom in here to the lake area of the watershed. And intuitively, you would think that the lakes within the Shaker Lakes would store stormwater or flood flows and be a benefit to the downstream portions of the watershed. But this is where our stormwater modeling has shown us that that's just not the case. And we're going to walk through some detailed information to illustrate how we've come to know that to be. So this just sets the stage of where the lakes are and really helps to illustrate that the Dome Brook watershed has issues or problems all up and down the watershed, and our modeling efforts were put in place to try to understand the potential solutions for those problems in the different communities and the alternatives that we could bring to bear and move forward as recommendations. And those recommendations sometimes change as we learn new information. So we'll move into the update for the Dome Brook restoration at Horseshoe Park, because this is a project that we're advancing after lots of discussion and public forums to understand the best way to bring this project forward. We're right at the 100% design stage, and we're moving through our federal, state, and local permits and approvals, and we hope to achieve those here in earnest over the next couple of months before we are able to move into our public bidding process and move ourselves into position to get under construction in early 2026. You can see the amenities that the member communities of Shaker Heights and Cleveland Heights are contributing to at the tune of nearly $7.2 million as a complement to the overall effort to remove the Horseshoe Lake Dam and restore Dome Brook, both its middle branch and north branch, into what will be a transformative 60-acre parklands within the Shaker Parklands. The district is contributing about $24 million towards that overall effort, and those dollars are focused under the Regional Stormwater Management Program on the stream restoration, the floodplain capture, and the wetland creation that will be in concert there to address and properly manage the stream flows of Dome Brook. And this illustration will show you what that proposed 100% plan will look like. You can see here the branches of Dome Brook, the middle branch, the north branch coming together just upstream of the former dam location. There'll be a new bridge crossing where the dam currently sits today to connect North Park to South Park. And then we're moving Dome Brook back into its historic channel downstream of the current dam or this new bridge confluence location as it flows towards Lee Road on to the west. And you can see the amenities throughout the park that the cities are contributing. And this illustration just shows you from an aerial view rendering of what this transformation will come to be. And so we hope to bring this product to the community here in 2026 through 2027 as we get under construction. And so let's focus back to the lower Shaker Lake and our findings under our stormwater master plan. So I'm going to walk us through where we are today and essentially a period of time. And time in terms of years are going to be important to understand as we go through this analysis. So the timeline, and I'm going to show a graphic here in a minute, but 2021, the district launched and was in the midst of our Chagrin River, Lake Erie Direct Tributaries Stormwater Master Plan. So this was a master plan that we had launched, again, to understand the different problems in the watershed and potential solutions to solve those problems. That master plan included Euclid Creek, Dugway Brook, and also Dome Brook. So Dome Brook is a part of that 2021 Stormwater Master Plan. And then we moved into the 2023, well, I'm sorry. And I think we would advance the slides here, John. And we'll just walk through the timeline here. So what I want to show you here is that master plan in 2021, where we had the initial recommendation based on the modeling that we had put in place, which was one-dimensional modeling, steady state modeling that we did in 2021. Again, it's planning level modeling to understand the different problems and solutions in the overarching watershed. So here we had determined that Horseshoe Lake Dam did not provide flood control benefit downstream. But Lower Lake, at that point in time, our understanding in 2021 did have notable flood benefit downstream. So we moved forward with the recommendation to reconstruct Lower Lake Dam. As part of that master planning effort, we were also inspecting the regional stormwater system, which included a 1 mile long culvert underneath University Circle. And we found debris in that culvert that needed to be cleaned, which if we were to clean that debris, in which we did, we were able to elevate that level of service for the specific areas of University Circle. So we moved that project forward and completed that in and around 2021 as well. We also recognized, which was an assumption under that 2021 stormwater master plan, that we needed additional culvert capacity with that 1 mile long culvert underneath University Circle. So an additional culvert or a sister culvert, if you will, within University Circle to help address or improve the flood conditions in University Circle. So we launched a feasibility study in 2023 and finished that in 2024, which taught us the different alignments that were possible. But yet at that point in time, we had not solidified a location of which alternative would be put in place. All along the while, we were working on the issues at Horseshoe Lake Dam because that dam was showing significant signs of deterioration, and we knew that we needed to move forward pre-design and design effort at Horseshoe, which I mentioned just earlier. In the midst of that, we also launched the pre-design in 2023 for the Lower Lake Dam reconstruction. So we were committed to the reconstruction of Lower Lake Dam based on our information that we had learned in 2021. In the effort to make sure that the Horseshoe Lake Park restoration project that included Doan Brook was effectively designed and controlled flows in terms of dampening velocities and dampening shear stress energy as that new streams and new stream alignment move downstream. We learned a lot about our modeling, and we put more modeling inputs into our modeling effort. And that was moved forward with these other elements where in October of 2024, we started to see a change in our analysis. And that was our pre-design effort. And then in January of 2025, we received our final report for our pre-design of the Lower Lake Dam reconstruction. And at that point in time, it was understood to us that what we thought was notable flood benefit of Lower Lake Dam being reconstructed in 2021 no longer had those benefits, in large part due to these factors that I'm going to talk about here moving forward. So let's first step back and talk about the Doan Brook watershed concerns. And I'm going to focus a little bit of attention on the Lower Shaker Lake Class 1 high hazard dam and its compliance issues. So we'll first move through that. And as we do that, it's important to note the different entities that have roles and responsibilities. So for folks maybe joining the conversation today for the first time, the Ohio Department of Natural Resources under their dam safety program, they're responsible for compliance of classified dams. In this case, Class 1 high hazard dams. And then we have the cities of Shaker Heights and Cleveland Heights, who are the dam operators. they're the responsible parties or entities to comply with the state's standards, in this case, the Ohio Department of Natural Resources. The city of Cleveland has a role to play as well. They're the underlying property owner and they're the dam owner. And they lease the parklands in long-term leases to both the cities of Shaker Heights and Cleveland Heights. And as we mentioned at the top of the webinar, the district has a regional stormwater management program, and we're in the conversation because we bring resources to bear to address issues, flooding, stream bank erosion, and improvement to water quality along the regional stormwater system, which is about 489 miles across all of our member communities in our service area. So that just sets the stage for the responsible parties involved. Specific to Lower Lake Class 1 High Hazard Dam, the dam is in non-compliance with the state standards. The dam, when it was built by the Shakers 180 plus years ago, it was not built to modern standards. It was not built to address flood control. And being a Class 1 high hazard dam, there is a potential for probable loss of life or significant property damage if that dam were to experience a catastrophic failure or an uncontrolled breach. So I'm going to pause here and just explain that there's a difference when we're talking about flooding. In this instance, when we reference the Ohio Department of Natural Resources role and responsibility, they're looking specifically at classified dams. In this case, it's the Class 1 high hazard dam to ensure the conditions downstream of flood impact if the Class 1 high hazard dam were to catastrophically fail or have an uncontrolled breach or release of the impoundment downstream. What happens? Under the Regional Stormwater Management Program that the district administers, we look holistically across the watershed at flooding, stream bank erosion, and water quality from our regional stormwater management system of operating the regional stormwater system, conveying flow up and down the watershed in an appropriate manner. So there is a difference between the two entities and how they're looking at flooding. Now, there are intersections within that. But specific to the Class 1 high hazard dam, in terms of Ohio Department of Natural Resources requirements, what the state requires is that that dam pass the probable maximum flood, 100% of the probable maximum flood. And that relates to the probable precipitation event, which is about 24 to 26 inches of rain in a 24-hour period. It's essentially a stress test on that dam facility to make sure that that dam can convey either through or over it in a safe manner during that type of storm event. That's what the state standards are requiring. So the current condition of the Lower Lake Dam, it only conveys about 2% of the probable maximum flood. So it's woefully out of compliance and inadequate. And it's not because of the way the Shakers built the dam. It's just the fact that we have different standards today in 2025 versus what we had in the past. And it's also not due to lack of maintenance. The cities of Shaker Heights and Cleveland Heights have performed maintenance on the dams at both Horseshoe Lake Dam and Lower Lake Dam. But irrespective of maintenance, the dams simply do not meet or match current standards, and reconstruction of those dams would be required to meet those standards. So those are the two choices that are basically brought before the two cities today: reconstruct Lower Lake Dam or remove it. And this map shows and graphic shows the multitude of deficiencies. And we're not going to go through all these deficiencies, but I am going to focus on one significant deficiency, and it's on the right embankment or the right side of the screen where it shows the elevation of 904.20. So that's a low point in the crest or the top of the dam. And that's where, and you may have seen this as we have rain events at Lower Lake, the flow or the lake escapes out the right embankment and spreads onto North Park Boulevard and into the Coventry intersection. And so that's a significant problem in the eyes of the Ohio Department of Natural Resources, because the embankment itself is made of soil and it's not protected with a hardened surface. So repetitive overflows or exasperated overflows could cause that soil to erode and lead to an uncontrolled breach or a catastrophic failure. So the next images show you what that looks like as we talk about how the high hazard dam is out of compliance and how it affects flooding immediate to Lower Shaker Lake. And we'll discuss how flooding occurs in University Circle. So if we go to the next images, this is the intersection of North Park and Coventry on the left in terms of the photo. And you can see just a little bit of the lake there. You can see Brook Road, Lover's Lane for some reference for some folks. But this is where the lake escapes out of that right embankment, that low point in the elevation. And the image to the right, the video, is showing you what that looks like. So this was in July of 2021. So at a 2-year event, which is a relatively low rain event in a 24-hour period, the lake can't escape. So again, this is an issue that ODNR needs to have addressed in terms of compliance. The overtopping or flowing over that earthen embankment jeopardizes the embankment in terms of failure. So this is what really is focused by ODNR. So if we move to the next series of graphics, we're going to show you what we've learned from the sewer district's perspective in terms of the flooding specific to this area of Lower Lake. And there's a series of design storms that I'm going to walk through that take you from the 1-year event through the 100-year event. And the 1-year event, you can see in the graphic, is about a 2-inch rain event in a 24-hour period. And then we're going to move all the way up to about a 5.2-inch rain event in a 100-year period. But this is using updated modeling, call this 2-dimensional mesh stormwater modeling. So we looked at new modeling as we were moving through those different pieces of the timeline that I mentioned at the top of the presentation, where we gained more information and refined our modeling to understand what's happening specific to Lower Lake in terms of its flooding adjacent to the dam. And so as we continue to move through the graphic here, you can see that the flooding expands in the intersection through the 100-year event. So this is an immediate issue right adjacent to the Lower Lake dam facility. And so the 100-year event in purple, you can see it covers the entire area. Now, when we move to the University Circle area, this is another problem area in the watershed. And as I mentioned, one of those 4 elements that help us address the flooding in University Circle is an additional culvert conveyance within the culverted section of University Circle. So this graphic shows you the Case Western Reserve campus, the Parkside dwellings, which had a water rescue in the recent past, one University Circle. Pay particular attention to the screen where it says Stearns Road and Martin Luther King Jr. Drive. This is where you're going to see the brook that's in a culvert in this area actually present itself on the surface as we move through the next series of slides that show our modeling graphics. So it's similar to what we showed at Lower Lake in terms of the flooding immediate to Lower Lake. This is another area of the watershed that floods. So on the right of the screen is the Cedar Hill area. And as the water moves down from the Cedar Hill area through through the Doan Brook Culvert, which is a 1-mile culvert underneath University Circle, you can see the flooding increases as we move from the 1-year to the 2-year. And once we get to the 10-year event, which is a blue color here that you see, that area at Stearns Road where it's labeled, that's where the Doan Brook Culvert actually is full and starting to present itself on the surface or surcharge onto the surface and starting to show significant flooding impact in that low point in the watershed. And as we move through the 25 and the 50-year event, we have greater precipitation from 4.5 inches all the way up to the 100-year event, which is about 5.25 inches of rain in a 24-hour period. You can see the flooding is quite exasperated in University Circle. But this additional culvert that we'll be able to install will help improve the flood conditions in that area. And I'm going to show you some graphics later on that will better illustrate that. So moving back to the Regional Stormwater Management Program and the addressing of flooding and dam compliance, as I mentioned, in June of 2021, we had moved forward with our master planning and made the recommendation to reconstruct Lower Lake Dam. And all the while, we had talked about removing the Horseshoe Lake Dam. So there's two projects moving in concert in the watershed and trying to understand how they work together. So the Shaker Lake timeline, again, is important to understand. That 2021 master planning findings taught us initially what was happening in the watershed. But the launching and the moving through the 2023 dam reconstruction pre-design showed us some additional elements that helped us understand what was happening in terms of the Lower Lake Dam reconstruction. So now I'm going to walk you through a few of the findings that we have related to the dam. And so there's really four elements to the dam reconstruction that we focused on back in October of 2024 that we brought forth to the public. And the first one is a concrete gravity dam. So as we mentioned, Lower Lake Dam is an earthen embankment and it needs to be replaced or reconstructed to meet modern standards, to meet ODNR's requirements. And to do that, we simply are going to build or would build a new concrete block to replace that earthen structure. And that's what it essentially looks like here in the middle of this graphic. So you can see just essentially a big concrete block that will stay in place if the dam were to experience that probable maximum flood or any high flow events. And so that protects the dam from having an uncontrolled breach. The next element that we'll show is the principal spillway. I'm sure that all of you recognize the stonework at the Lower Lake Dam, and that is the principal spillway. That's the main outlet point of the Lower Lake into the Doan Brook, and all of that would need to be reconstructed. So that's the second main element that would need to be constructed. And then the third element is an auxiliary spillway or a secondary spillway. And so in order to convey flows completely to address the probable maximum flood, we need an additional spillway. And so the graphic that you see here shows what that would be. It sits out in the lake. It's made of concrete. It's quite obtrusive. And you can see that it is necessary to convey these larger flows. And I'll also mention in this graphic, you can see the trees that are currently between Lower Lake Dam and Coventry Road. Those would need to be removed because the dam height there is too high. Again, we're going to have to convey flows through and over the dam during that probable maximum flood event to match or meet the state's requirements to be a compliant Class 1 dam. Then the last piece of this are the flood walls. And so the flood walls are necessary to train or direct the flows of Doan Brook upstream of Lower Lake through the lake and over the dam, not allowing those flows to escape out of the lake as they do now onto North Park and Coventry intersection. So those flood walls at the current dam location were to be 8 feet tall. And then they taper back to about 2 feet tall, 2.5 feet tall as you approach Fairfax back to the east. And there's also flood walls on the South Park Boulevard side. So again, these were pieces of information, large civil works that we were learning that were necessary to be constructed to reconstruct the Lower Lake Dam. They come with great expense and they're quite obtrusive and aesthetically not pleasing to the park landscape. So again, these were elements that we were considering as part of our evolution of information. So that's the dam reconstruction itself. And so the other part of this overall effort to address issues within the Doan Brook is the additional culvert and University Circle. So we're going to talk about and move through some graphics here on the additional culvert. And as we do that, it's important to understand that there's, as we were going through and mentioned before, we're collecting more data. There's more modeling inputs. There's refinement to those modeling inputs and data analysis that allowed us to understand the information and the decision point that we've brought forward here in 2025. So some of those elements, when we did the 2021 Stormwater Master Planning, we had one monitor in the watershed. Again, it was a planning level, one-dimensional modeling effort in 2021. We deployed 6 additional monitors in the watershed, up and down the watershed, to capture more data. We also introduced or input into our model, our updated model, actual storm events that helped us calibrate and revise the model. So these are elements that helped us get a truer or more accurate understanding of what was happening throughout the water and specific to University Circle, which was a problem area that we were trying to solve. And this next graphic is going to show you the difference between the 2021 modeling effort in terms of the drainage network that we knew and understood and had put into that modeling effort in 2021 versus the revised modeling or additional inputs that we input into the new model. So you can see on the right, there's much more yellow lines. Those are local storm sewer inputs that we added to the model. So again, greater inputs pushed out greater accuracy in terms of what's happening in the model. In addition to that two-dimensional mesh modeling, which helped us understand how water was moving over the surface of the watershed, flowing into catch basins and through local storm sewers and draining into the brook. So all of this information was giving us that truer, more accurate depiction of flood conditions on specific assets within different parts of the watershed. And so next, we're going to move you through the modeling updates and show you what that means. So we can advance to the next slide here. And as we show you these new updates, this is the graphic that shows you that effort of the 2023-2024 feasibility study specific to the additional culvert in University Circle, that sister culvert, if you will, to the existing 1 mile long culvert in University Circle that conveys flows or conveys Dome Brook through or underneath University Circle. So the blue line that you see in this graphic is the existing Dome Brook culvert, and it's a single barrel at the bottom of the screen. As it moves to the top of the screen, it splits into 2 barrels and then back into a single barrel or pipe, if you will, moves underneath the North Family Greenway. And at the very top of the screen, you can see the open channel of Dome Brook, where Dome Brook surfaces back onto the landscape at the Cleveland Museum of Art. The study, the feasibility study, the different colors that you see are the different alignments, the different possibilities. So in 2021, we knew or we desired to have this additional culvert because that was the assumption that was made. More capacity, we can raise the level of service or flood condition or improve the flood condition in University Circle. But we didn't know where we could build it and exactly how we would build it. So fast forward to 2023 and into 2024, and we are working with the Cleveland Museum of Art as they move through a rehabilitation or renewal of their fine arts gardens. And so the image that you see on the screen, you see a large yellow arrow there. That orange alignment is the alignment that we are working with the Cleveland Museum of Art to capture and build the additional culvert capacity underneath Wade Lagoon. Fortunate for us, the Wade Lagoon will be drained and rehabilitated. And so that provided an opportunity for the district to partner with the Cleveland Museum of Art to capture this additional culvert. So we're working through the arrangement to make that happen, which sets the stage for us understanding the flood condition improvement that we have in University Circle based on that. And just to note, there's no interaction between the Wade Lagoon and the culvert. They're separated hydraulically. They're Wade Lagoon is simply a surface pond. It doesn't have storage for the Dome Brook. It's not connected to the Dome Brook other than just outletting into the Dome Brook. So we're going to walk through this analysis and show you some of the information that we learned in terms of our refined modeling effort based on this additional culvert conveyance. So again, here we are at the Case Western Reserve campus in the Stearns Road, Martin Luther King Jr. Boulevard area. And so there are three modeling scenarios that we'll share this evening. One, we'll show you with the existing Lower Lake Dam, without the University Circle culvert or this additional culvert. And then we're going to show you two scenarios where we have the University culvert installed in place with that additional conveyance and that additional level of service that it provides for University Circle. And one of those we'll show you with Lower Lake Dam and one without Lower Lake Dam. So we'll just move to those graphics. And the first graphic that you're going to see is, again, no additional culvert in University Circle. So this is the Case Western Reserve campus buildings and the buildings within University Circle. And you're going to see two polygons appear. And in the circle polygon, you're going to see two buildings. One is in purple and one is in light pink. And you can see the level of services that they match in that design storm legend. So the purple building's at the 100-year level of service and the pink building is at 50-year level of service. And then the polygon below shows that those other two buildings. So under this condition, again, this is the existing University culvert, no additional culvert with the Lower Lake Dam. There are 13 buildings that flood at the 100-year event. As we move to the next graphic, we introduce or put in place the University Circle culvert conveyance. And what our modeling has shown us is that those buildings that were circled or in the polygon, those buildings are now protected to the 100-year level of service or raised to an improved level of service. In fact, they come off of our asset list. So we moved from 13 buildings in University Circle to just 9 buildings now flooded in University Circle, based on that additional culvert conveyance capacity in University Circle once we build that capacity. The third graphic that we'll show is the difference between having the University Circle additional culvert conveyance with the Class 1 reconstructed Lower Lake Dam. And so this is the difference between those two scenarios. And it's really, and what we're focusing on here is one building in the Case Western Reserve campus, the Wickenden Hall building, which is already flood proof to a certain degree. But essentially, if you look at the image in the middle at the Wickenden building, which is the arrow that's pointed to, it's a 25-year level of service without the Class 1 dam and the culvert installed, the additional culvert installed. The image to the right shows the Wickenden building only raised to the 50-year level of service with the Class 1 dam. So it's just one building in University Circle that receives flood condition improvement based on the reconstruction of Lower Lake Dam. And so that's what our modeling showed us in terms of results. Again, the additional culvert in University Circle is important to University Circle, not necessarily the Lower Lake Dam, in terms of improving flood condition in University Circle. And we know that the area immediate to Lower Lake Dam can be solved with removal of the Lower Lake Dam, as we are able to appropriately convey flows through what will become the new stream valley at that location of Dome Brook. So moving to the next slide. These other considerations were also part of our equation. There's ecological impacts to dams. Removing dams increases water quality and brings a general ecological uplift to a watershed. We also need to consider the ongoing maintenance and operation costs of a Class 1 dam. Yes, there are life cycles for the dam components. Some components of the dam will have a 50-year life cycle. Some may have much greater life cycle. All of those components will need ongoing maintenance and operation costs to ensure that the dam operates as it should and meets any state requirements. And also, a last point is the insurance and liability of the cities as dam operators. So there's certainly a consideration from a business risk assessment for the cities to consider as owners and operators of a high hazard Class 1 dam. So all these factors were part of our broader process and equation and evolution of the recommendation that, as I mentioned before, began in 2021 with a commitment to reconstruct Lower Lake Dam, but then through additional analysis, understanding the changes and greater information, the greater accuracy, moving to and towards a revised recommendation that we brought forward here in 2025. So just to summarize, the district now is recommending to remove the Lower Lake Class 1 high hazard dam. And we're going to continue to pursue our efforts to put in place that additional culvert capacity in University Circle to capture that flood improvement that we now know that we can establish based on our opportunity with the Cleveland Museum of Art. And so just to touch on and discuss the costs, there are two costs basically that are part of the decision-making process. To reconstruct the dam, based on the district's pre-design effort, we now understand that that cost is in the neighborhood of $43 million. There's a component to that cost in terms of the sediment that's within Lower Lake. There's about 140,000 cubic yards of sediment within Lower Lake. If one were to reconstruct Lower Lake Dam with those elements that we discussed earlier, you would need to navigate and deal with about 5,000 to 6,000 cubic yards of material. But in order to have a fully rehabilitated lake with a new Class 1 dam, the cost of that sediment removal or adjustment, if you will, is about $12 million. So the overall cost to bring Lower Lake to a better quality with a new Class 1 dam is $55 million. Now, if we were to remove the Lower Lake Dam and restore Dome Brook to a corridor that contains floodplains and wetlands, and we dampen flows like we do at the Horseshoe Lake Park project, that's a price of about $37 million. There's some additional culvert work that we would need to do downstream of the dam, the lake at Coventry and Farrell to make sure that those flows flow appropriately on down into the gorge. And so that cost is really truly about $45 million. So there's the cost difference. It's $55 million to reconstruct the dam and rehabilitate Lower Lake in its entirety versus dam removal and stream restoration at a $45 million cost. Now those costs for dam reconstruction are costs that now that the district understands what is now not notable flood benefit downstream of Lower Lake Dam cannot be paid for under the Regional Stormwater Management Program. But the Regional Stormwater Management Program, because water quality is one of our 3 pillars of implementing the stormwater program, we can assist the cities if they were to choose to move forward with the removal of the dam, to remove the dam and rehabilitate or restore the Dome Brook in its corridor at that cost of roughly $45 million. So those are the cost points associated with the recommendation today. And so just to summarize, again, that points in time are very important to understanding how this recommendation has changed and evolved over time. 2021 Stormwater Master Planning, we had a set of information at that time. We committed to the lower lake reconstruction. But as we moved forward in understanding the feasibility of the new additional culvert in University Circle, we better understand now that we can address that conveyance issue in University Circle. That additional culvert analysis was part of our equation, but the refined modeling effort that came forth from our efforts to ensure that we designed the appropriate project at Horseshoe Lake Park helped us understand the flood condition throughout the watershed and proved that the lower lake dam just simply does not provide notable flood benefit downstream, and therefore was the opportunity to revise the recommendation for additional reasons, ecological uplift reasons, the cost of the project escalating due to the heavy civil works, in addition to the aesthetics that were going to change the current status of the park landscape as we would know it today. So those are the elements that were evolving together in concert. So we'll continue this discussion and we'll continue our efforts in the University Circle area as we move into a pre-design effort to, again, solidify that additional culvert capacity within University Circle. And so as we had mentioned in past presentations, we will be at the Lee Road Library in Cleveland Heights tomorrow at 11 a.m. and there till 1, and then we'll again be there in the evening in person 5 to 7 to answer questions and further discuss the revised recommendation to the cities. And as always, we have our website, the Lower Lake website, where you can see all this information and additional information. And our watershed team leader, Cisco Rivera, is our main point of contact. And Cisco will be with us tomorrow morning and afternoon to help answer questions.
Great. Thank you so much, Matt. We've been answering quite a few questions within the Q&A function, but some of the questions we received have a little bit more nuance, or it might just be a little bit easier to explain those in person with my wonderful panelists. So you've already had the opportunity to meet Kyle and meet Matt, but I would like to also welcome Kim Kolish to the conversation. She's our Stormwater Program Manager, and I'm very glad that she's here today because I do have my very first question for Kim.
Great.
And in the chat, there seemed to be a little bit of confusion about the X year storm event. So talking about a 10-year event or a 25-year event. And I always personally like to think of it as a percentage chance of something happening. So a 10-year storm might have a 10% chance in any given year, 25-year 4%. But maybe you could explain that a little bit further and provide some inches within a 24-hour period that might help sort of frame it so that people can get a better idea of just how much rain that is in a certain amount of time.
Yeah, absolutely. I can do that, Jen. And I think you explained, most of that question very well, the answer to it. So when we're talking about storm events, like you mentioned, a 10-year storm has a probability of happening 10% in any given year, right? Or once every 10 years, right? But when you look at the actual rainfall events, and I think people are always interested in what does that rainfall event mean for those storms, we look at something like a 1-year storm. We talk about a 1-year storm. That's about 2 inches in a 24-hour period. If you go up to the 10-year storm, that's about 3.5 inches in any 24-hour period. And then when you get to the 100-year event, which we talk about a lot, we're looking at about 5.4 inches over a 24-hour duration. So those are the storms we use within our program and our industry standards that are used in order to size stormwater management facilities.
Perfect. Thank you so much. And then let me see, what other questions do I have that are in here? Oh, this is one I always find really interesting from folks, is talking about like not only climate change and just overall like warmer weather, but how would the effect of changing this from a lake into a restored stream affects like wildlife and different foliage and trees and things that people come out to the parks to see. So I don't know which of the three of you would like to answer that one, but I think that's another really great one that we get a lot.
Go ahead, Matt.
Yeah, I'll start off. Certainly, lake environments have their host of habitats and benefits. Stream environments have a different host of habitats and water quality. And I think in this instance, when we look at the differences, stream restorations bring a greater or a general uplift to the ecology of the entirety of the watershed. So online or inline impounded water bodies can be damaging or detrimental to water quality. So when we're really focused on Dome Brook, stream restoration brings an opportunity to improve water quality if we're able to remove water bodies from being online within the brook.
Yeah, and I would just add to that, Doan Brook is a brook. It's not a lake. So I think that's, the underlying ecology is a stream ecology. And so when you're doing this stream restoration, we're bringing back the existing and the natural watershed function that is in the Doan Brook watershed and rebuilding that. And then obviously the projects that we build, we maintain and we take care of those projects going forward.
All right, and speaking of projects and project planning, there's another really great question, and we're talking about modeling and the modeling that we looked at during pre-design versus the modeling that we've more recently looked at now. And could we talk a little bit about why these modeling enhancements weren't done earlier in the project life cycle and why we waited until 2025 to look at the 2D mesh modeling?
Yes, I think I'll start and then I'm going to ask Kim to add in. But I think it's important for folks to understand that in 2021, when we were doing the Chagrin River Lake Erie direct tributaries modeling, we were looking at multiple watersheds over a large area of our service area. And so that was a planning level effort, a high level effort to gain an understanding of the problems in the watershed, potential solutions. And so we didn't have all the tools in terms of modeling capacity available at that time, and we didn't deploy them all at that time because, again, we were trying to get a greater understanding or a planning level understanding. So as we move through, and oftentimes we do with projects, we look to refine the modeling, gain a greater understanding specific to a project or a problem area to make sure that we're matching that up with the right solution. So I think Kim can talk about how we moved to that two-dimensional mesh modeling and what that really meant for us in our ability with some new tools, new technology, better application of inputs into the model to gain those results that I talked about earlier.
Yeah, I can add in, Matt. I think, to the original question, timing of it. So when we take projects from master planning into pre-design, into a project, pre-design, and then ultimately a detailed design, we are doing that work through the pre-design to look at alternatives within the recommendations of the master plan, what makes most sense. We're doing surveying. We are doing additional extensions into our model system. We're adding all those components so that the model is more refined, so that we have better solutions, better designs of the projects as we're in pre-design. So part of pre-design is really gathering all that data, updating those models, and making sure that we are moving in the right direction moving forward with the information that we are gathering. So that's really critical. As part of Doan Brook, outside of just the pre-design of Lower Lake, there was a lot of projects, a lot of studies, a lot of refinements happening all at the same time. We had the Doan Brook restoration at Horseshoe Park that was happening. We had the detailed design there. Matt had talked about how that modeling effort has informed the overall Doan Brook stormwater model itself. So not only that, but then the tools, as Matt mentioned, this 2D mesh that we were able to incorporate. And really what the 2D mesh is able to do is show us how the runoff is moving over the surface. it has a better representation of how water gets on the surface, back in the system, and back out of the system. And it's more dynamic than a static model. So those tools are now available to us, and we use them in this process for the Donebrook model in order to get these better results from our better data.
And thank you so much, Kim. And actually, there's a question for me. So it just came through, so I'll actually take it. Somebody is wondering if some of the modeling data will be accessible to the public for viewing. And so my team and the watershed team leaders within watershed programs, we do a lot of stakeholder engagement, where we're always trying to meet our customers where they are by coming out to public events, hosting our own events, things along those lines. So we have been in conversation about doing a workshop about how the modeling works, what we find, the types of things that we put into it. So that's definitely something that we're looking to do, almost like a lunch and learn, or something where we'll do it, have a program online, have people have an opportunity to come in. We can look at some real-time data and we can put all of that together. And also, if the cities do decide to move forward with our recommendation, we will have the same level of stakeholder engagement, public meetings, all of that stuff that we did with the Donebrook restoration at Horseshoe Park project. So we will still continue to meet you where you are, whether it's Apple Fest, Autumn Fest, Take to the Lake this weekend, things like that. We will be out there, but then we'll also have events like this where we'll have webinars, we'll have public meetings, and we're here to answer the questions that you have. So if you do have questions, if you do have concerns, by all means, feel free to reach out to us. You can email us at, again, it's askus@neorsd.org, or you can reach out to our customer relations team at 216-881-6600, or as Matt mentioned earlier, the watershed team leader for this section or this area, it is Cisco Rivera, and his email address is riveraf@neorsd.org. So any of these ways, we're always available, accessible, and here to answer questions for you. And then there is another question. Sorry, I'm like answering questions and getting questions, everybody. So bear with me for 1 second. There's a whole lot of stuff coming through. So there's a really great question in here. So we're talking again about the 8-foot wall. And if the cities decide to move forward with our recommendation, will that 8-foot wall still be there?
Yeah, so I guess the question is, will the 8-foot wall be there if the cities move forward the district's recommendation, our current recommendation? So our current recommendation is to not reconstruct the Lower Lake Dam. So that would mean the 8-foot wall would not be constructed. If the cities were to choose to move forward on their own with other resources and reconstruct Lower Lake Dam, there would likely need to be an 8-foot high concrete wall to some degree there. And again, necessary to direct the flows or train the flows over the new dam. So that's what would need to occur.
Thank you. And there's another one that's probably actually for any of the three of you, whoever would like to take it. And the question is, to what extent could removing impervious surface or adding additional green infrastructure mitigate the flooding at Lower Lake that Matt mentioned earlier during some of these large storm events?
Yeah, unfortunately, much, if not all of the watershed in Donebrook is highly urbanized. Certainly, we welcome any opportunities to add storage, green infrastructure, stormwater management in the watershed. But it's a very flashy, fast-moving watershed. The brook itself and the topography of the brook is downhill, so the profile is steep through the corridor. So it's challenging from a watershed management standpoint and a stormwater management standpoint to integrate back into the landscape enough storage to have meaningful impact to change the trajectory of these bigger problem areas in terms of flood improvement.
And let's see, I just had another really great one. Can we that was a question. That's a very similar question. Okay, so there's one more that I think is a really great one, but it's a little bit long, so bear with me, everybody, as I go through it. And the question is, in our earlier recommendation, so the recommendation to reconstruct Lower Shaker Lake Dam, which was alongside our work to remove Horseshoe Lake Dam and restore Dome Brook. The decision was made to reconstruct the Lower Lake Dam because of its ostensible flow benefits. The language was presented to our stakeholders as if it were a final conclusion. But was that recommendation made with the belief that the data and modeling was already complete, or should it have been maybe approached a little bit more cautiously, as we thought maybe more information might come in? So Kim, I don't know if you want to take a stab at that one.
I think Matt unmuted. Matt, did you want to handle that one?
Go ahead and start, Kim, and then I'll.
Yeah, I mean, I think we talked about our process here, right? Our process of going from master planning into pre-design when projects are up for that next phase. And that's how we do all of our projects, both on the stormwater and the wastewater side here at the sewer district. So I think that's the approach we took there. And I think that's the approach we would continue to take on any project.
Yeah, and I'll just add that it's important to recognize again that in 2021, it was a planning level effort of modeling. Again, we were looking at multiple watersheds. Certainly Dome Brook was part of that. In 2021, we were also grappling with the issues that were before the cities in terms of Horseshoe Lake Dam and its quickened pace of deterioration. So there were many factors that were, in the equation at that point in time when we committed to the reconstruction of Lower Lake Dam. Certainly, we know more information now than we did back then. And it's led us to a different conclusion. But in 2021, we were at a planning level effort in terms of our master planning understanding.
I think also, Jen, I would just add to that these are large civil projects, and folks can see from that timeline that Matt detailed that it takes a while to move through feasibility, pre-design, and design. And each step along the way, you want to make sure that you're doing it correct. So you need to check your work with more and more refined information. And so we needed to get to work on the Lower Lake Dam reconstruction pre-design. You can see how long that took. And I think one of the other questioners has raised the point, why is it taking so long at Horseshoe? It's taking so long at Horseshoe because we went through an extensive public engagement and public involvement process, an extensive design process, and then we're going to move that large project into construction in 2026. So these projects take a while, and you want to get started on them and advance them through the process. And then we also always are up against the fact that we have these two dams, the one at Horseshoe and the one at Lower Lake, both of which have, at Horseshoe, you have the demonstrated, documented structural instability issues, and at Lower Lake, you have the profoundly out of compliance with dam safety standards.
So the next question I have, and there's a second question, so I might just add a little bit to the end of this one, because I think the two can go hand in hand. And the question is, so if this current Shaker Lake Dam doesn't have a flood control benefit, you might consider that because it's so shallow and there's a relatively low volume of water stored, that a dam break or a breach during a 20, 50, or 100-year event wouldn't have a significant effect on downstream flooding. Is this true? And had your modeling looked at this, that a dam break would only release a small amount of water during a major storm event? And I think to couple that, I think if we could touch a little bit on the emergency action plans associated with this dam, I think those two things go hand in hand. So the person who asked that related question, I'm just going to categorize these two together for you.
Yeah, I think I'll jump in if that's okay. As part of that emergency action plan for any dam that's classified by ODNR, it's required to look at a dam failure analysis or a dam break analysis. And ODNR has specific requirements for modeling to do that analysis, That analysis has been done for Lower Shaker Lake. And so they looked at the impacts of the dam break on any assets downstream. And because of the downstream hazards, that's why ODNR has classified this dam as a Class 1 dam. So that dam break analysis is the evaluation that showed the impact to those downstream assets should the dam have a catastrophic breach during a storm event. So we do have all that information in the emergency action plan, that's there for information for anyone.
Hey, Kim, just go upstream 1 second though and explain that the cities, as the operators of those two dams, Horseshoe Lake and Lower Lake, are required by ODNR dam safety standards to have these emergency action plans. Those aren't sewer district documents.
Sorry, that's correct. That's correct. The operators of the dams are the ones that are responsible for the emergency action plan. They're also in charge of the operation, maintenance, and inspection plan that is required by ODNR. And so the cities are the responsible parties for that.
Thank you. And somewhat a related question just about the dam
Jen.
itself.
Hey, Jen, sorry. I'm not sure we fully answered the question though, because the questioner is saying, and we've talked about this, that Lower Lake has a significant amount of sediment in it right now.
Oh, yes, true. Absolutely. I'm sorry.
So Matt, do you want to get to that? Because it's, as all the questions are, it's a really interesting question.
Yeah, so, as Kim mentioned, the dam break analysis, part of the state requirements, as dam owners, operators, you need to understand what the potential impacts are downstream. And that's ODNR's job to ensure compliance. So, they're looking at wet weather events. They're looking at, if you had a sunny day event where the dam were to catastrophically fail or have an uncontrolled breach. So, as you move downstream from Lower Lake Dam, you quickly move to Coventry, and you've got a culvert there. If that Lower Lake Dam were to fail, you would have an issue at Coventry. The road would be overwhelmed. You possibly could lose that culvert crossing. Then it moves on to Fairhill Road. Again, that culvert could be compromised. That roadway could be lost. So you've got transportation on those two roads. Then you move into the gorge. As you move through the gorge, and again, this is going to be a flow of water, a wave of water, if you will, that's carrying sediment and likely debris as it picks up additional debris in the corridor. That's going to move through the gorge at a quick pace and hit likely the debris rack that's just upstream of the Martin Luther King road crossing or culvert crossing there. That's another impediment that would likely be overwhelmed, compromised. Then it would move through and possibly over another dam facility, Bemba Dam, that's in the gorge, that's just upstream of Ambler Park. Ambler Park is the beginning point of the culvert, which is the opening that swallows up Dome Brook and carries it underneath University Circle. If that opening were to be compromised because of a dam break, dam failure, uncontrolled breach, that would likely be blinded or covered by debris, not be able to carry that capacity. And so it would jump out of the brook there, like it has done in the past, and move right into University Circle to the RTA station, and then start to fill the bowl. In a wet weather condition, yes, University Circle is already experiencing flooding. This would exacerbate or add to that flooding. And that's the importance that ODNR brings to the table in terms of they're requiring the dam owners and operators to understand what happens in a dam break analysis so that the dam is not doing that and adding to potentially a disastrous situation downstream.
That's great. And there is a related question that actually just came through. And it's looking at, it's a little bit more of a modeling question. So if the new dam is required to pass 100% of a flood event, what would the difference be between having the dam there with it passing all of the flows from a large rain event versus not having the dam and those flows continuing to go downstream along Dome Brook? I rephrase that, but that's the gist of what we're looking for.
Kim, you want to lead us off on that?
I'll lead it off and I'll say that I think you hinted at it with your other answer, was that it exacerbates the flooding that's moving down Doan Brook. You know, a catastrophic failure of that dam would cause a additional wave of flow with that debris, with the height of the water. So it would exacerbate the existing flooding that was already happening. So I'll just start there.
I just
Yeah, and
want
I
to make
think-
sure we understand the question though.
Yeah.
Jen, I think what the questioner is saying is, you're talking about the probable maximum flood from a dam safety perspective. How can you make a stable stream in that
Yeah, so the
location?
actual question is, here's the simplest question. Would completely overhauling the dam alleviate the issues and have the same impact? I think that is one of the things many are curious about. So for the questioner, if I completely misparaphrase your question in the first place, but I think it does it does fall to with a dam and no dam, how do you still not have flooding in University Circle? That's how I'm seeing it. So Matt, I don't know if you want John to pull those images back up. I know he'd be happy to do that for us.
No, I think it's, again, to reiterate, the class 1 identification of the high hazard dam, ODNR's requirement is that that dam has to meet and be able to convey the probable maximum flood. That's that 24 to 30, 26 inches in a 24-hour period.
Because
I think what-
ODNR is only focused on the stability of that dam.
Correct.
They're
That
not
asset
focused
alone.
on flood control of that dam.
Right. They're not looking at flooding throughout the watershed. They're looking at the flooding that would occur specific or from that facility, that dam, if it were to fail. Now, under the probable maximum flood, yes, it's correct to understand that we're likely all in trouble. And the surrounding areas will be flooding. That's not the job of the state. That's not the job of the dam safety program. The dam safety program is in place to make sure that the dam doesn't fail and that it can convey that flow safely and not contribute to additional catastrophe that might be happening under the probable maximum flood event. Under the Regional Stormwater Management Program, we're looking at our level of standard is the 100-year, that 5.25-inch rain in a 24-hour period or greater intensities and shorter duration of time. So we're looking holistically across the watershed to address that issue. But again, these significant events, yes, we concur that there's going to be flooding everywhere. But under the stormwater program, our efforts are to raise the level of flood protection throughout the watershed. And that's what we've tried to illustrate this evening in terms of specifically University Circle and immediate to Lower Lake Dam. We can't achieve that through removal of the Lower Lake Dam. That's why the modeling is so important to understand, to assure that if the choice were to be made by the cities to move forward with removal of the dam, that the removal of that dam does not cause problems downstream. And that's why that modeling effort is so important, because we've now shown that we can remove the Lower Lake Dam, take advantage of the valley that the lake currently sits in or is now filled, and capture floodplain in the valley and appropriately move those flows through the valley without causing downstream harm.
And I do have another question. It was answered in the answer tab on here, but I think it's really great for everybody here because it comes up with every project, whether it's these two projects or projects across our service area. And it deals with maintenance. And the specific asker is wanting to know who would be responsible for maintenance if the cities decide to restore the stream and reestablish floodplain and invasive species management, all of that. What part would fall to the cities or what part would fall to the sewer district?
So under the Regional Stormwater Management Program, things that the program builds and constructs, we maintain. We maintain that in perpetuity. So much like what we're doing at the Horseshoe Park project, restoring Doan Brook, the north branch and the middle branch of the brook, building new floodplain access, creating wetlands to address local stormwater inputs before it reaches the brook. Those components of the project, this Regional Stormwater Management Program will operate and maintain. Horseshoe Park project, it's about 26 acres of that over all 60 acres of that, the parklands. So it would be a similar situation at Lower Lake Dam. Again, if the cities were to choose to move forward with a stream restoration, we would make great efforts to match a similar project, stream stabilization, and that would come with our efforts and commitment to maintain that new stream corridor, complete with its floodplains and wetlands that we would create to address the correct management of flow in the brook.
And there is another question in here about sediment sampling. And I know we did a lot of that with the Dome Brook Restoration at Horseshoe Park project, but could we talk maybe about any sediment sampling or any other studies or research that we did with the Lower Shaker Lake Dam reconstruction work? So maybe anything in the pre-design that might still be of great use and great interest as we move forward. I know we did some soil borings, things like that, but if we could maybe talk about some of those pieces, Kim.
Yeah, and I'll use Horseshoe Park project as the example. We did extensive testing of that sediment several different times and several different locations and depths of sediment, because obviously the sediment at the bottom of the lake may be different than the sediment at the top of the lake from what's in it. So we did lots of sampling on that, both to understand any contaminants as well as understand the soil properties, both of which are very important to projects like this. Obviously for contaminants, we need to know if they're there. For soil properties, we need to know how the material can be managed, how it could possibly be amended or hauled off site, so that our contractors understand what to expect when they're out in the field moving around the sediment and managing the sediment. So we did extensive testing. Like I said, as example at Horseshoe Park, we found very normal, typical petroleum-based products in the sediment as a runoff from oil and gas on roadways, but nothing that was concerning to us, nor concerning from the results that we got from any contamination levels. So we're set to go on that one. And at Lower Lake, we would do a very similar process, I believe. We did sample some sediment closest to the dam because, again, on the Lower Lake dam reconstruction pre-design, we had focused on replacing the dam in its current location. And so we focused on sampling the sediment right next to the dam, the sediment that would be potentially removed or moved around as part of that specific project.
And
there
Jen,
is a
before,
question. Oh, go ahead.
Jen,
Sorry.
before we go to the next one, I'll give you some time there. Soil borings are an interesting piece of data collection. They tell us a lot. And in this case, understanding the sediment in the lake was important, but also understanding the underlying bedrock is important as we were looking to reconstruct Lower Lake Dam. So in 2021, we had some assumptions, limited data on the bedrock. And as we progressed through the pre-design of the Lower Lake effort to reconstruct, we did additional borings to understand the sediment, but also to understand where the bedrock's at. How are we going to anchor this new gravity concrete dam to the existing bedrock? We didn't understand that in 2021. In fact, we weren't even talking about a gravity dam necessarily in 2021. So these are the reasons why the costs have escalated or risen. It's not as if we didn't know what, how to reconstruct a dam per se, but how you would do it at Lower Lake. With the conditions and the constraints that are there, that exist, that really can't be navigated around completely. So it's just another example of that data collection, that thoroughness that you have to do in a pre-design effort to move yourself to be in a position to scope a project correctly for design effort, and then understand what the true costs of, again, we mentioned this, it's a significant civil works project. And that's why these costs have moved up to the levels that they have.
Kyle, I'm going to toss this one your way. If the Lower Lake is drained and we move forward with the stream restoration project, do you have a sense of how that area will look?
Do I have a sense of how the area
Yes,
would
do you
look?
have a sense?
So, when I think about this project, as someone who lives in Shaker and uses the Lower Lake, I'm a runner, walker, bike rider. I really think that in my perspective, it'll look much as it does now, with a restored stream, the connection between over the dam as it is now, that connection around the park, trails around the park, that passive recreation vibe that you have now at Lower Lake. But instead of the lake, there will be the restored Doan Brook. So that's how I think of it when I walk around the lake now and sort of try to get a sense if the cities do decide to move forward with the stream restoration, it will be quite similar to the passive recreation experience that you have there now.
Thank you, Kyle. And I think we're getting kind of towards the end of the questions. But maybe I think there's maybe a couple of points that I'd like us to just sort of reiterate because they're still coming up a little bit. Can we explain again why, if cities decide to reconstruct Lower Shaker Lake Dam, how and why the sewer district cannot be involved in that decision moving forward?
So just quickly, and then there's one other thing I wanted to add to this because
Sure, absolutely.
I've been thinking about this a lot. So the sewer district can only do projects that are consistent with the tenants, with the purpose of the regional stormwater management program. And we have that responsibility to all of our customers across our whole service area. So with our updated information that we talked about today, we now know that an ODNR compliant dam at Lower Lake does not provide these notable flood control benefits. And so we cannot do that project under the Regional Stormwater Management Program. So I know that that's a lot, it's a lot of information, but it's not something that we can do under the program. I've also been thinking that I think folks may think that we're talking about the Lower Lake Dam as it looks today. And that is not something that the sewer district ever would have reconstructed because we would have needed to reconstruct something that was compliant with ODNR safety standards. So that I think is really not so much a nuance, but a point to this conversation that we haven't really emphasized enough. And I don't know, Matt, if you want to clean up what I just said, I sort of went all over the place, but this idea that what we're talking about, if the sewer district were able to reconstruct a dam at Lower Lake, it would be the ODNR compliant Class 1 high hazard dam. And that would look nothing, as we've talked about tonight, it would look nothing like Lower Lake as it looks today.
Thank you. And I think we've just got a couple more that are in here. So in a 100-year rain event, with the restoration of the creek and the floodplain, and the secondary culvert, would that be enough to slow down and capture the water better than a dam might contain the water? We're seeing major floods across the South and most recently in Milwaukee just a few weeks ago. So the 100-year level of design storm, they're obviously going to be a problem in the future. So would a restored brook and reestablished floodplains with a secondary culvert, would that be enough to slow down and capture the water better than a dam?
Well, that's a great question, Jen, and that's our job as administrators or implementers of the Regional Stormwater Management Program. You know, again, if the cities were to choose to remove the Lower Lake Dam and want or desire a restored Doan Brook, that's where we continue to sharpen our pencils and make the same effort that we did at Horseshoe Park in terms of ensuring that we're not transferring problems downstream. So again, we would launch right into a pre-design effort specific for a restoration of the brook within the footprint of Lower Lake to understand what space do we have, what can we work with, how much floodplain can we capture, the configuration of the brook itself, how does it dampen down velocities, how does it address shear stresses. So, and we would do that. Our goal is to match and meet the 100-year level of service. And so that would be our effort to get to that. So that's very similar to what we did at Horseshoe Park, where we've shown, again, through our modeling, that we're achieving that at that location, and we would work to achieve that here at Lower Lake.
And I don't know if anyone who is on the webinar today was able to join us at the Nature Center at Shaker Lakes last night, but we did participate in IdeaStream Public Media's Sound of Ideas community tour. And that will air at the normal Sound of Ideas time this coming Monday at 9 a.m. And one of the things that came up during that conversation, and there is a question that just came through now, is there a middle ground? And could a smaller lake exist within the lower lake parklands?
I'll start the answer, and then Kyle or Kim can certainly weigh in as well. But we certainly have heard that. We acknowledge that. There's an opportunity perhaps there that we're willing to explore. If, again, the cities choose to move forward with a stream restoration effort. There's some serious constraints to this space. From a topography standpoint, from a hydrology standpoint, we would need to be cautious in our understanding of the placement of a water feature, the size of it, how it would operate, how it could be maintained into the future. There'll certainly be costs for some type of a feature like that, but we can't really answer any questions definitively about that until we get into the pre-design effort. And I think we've acknowledged already that we're willing to add that to and be inclusive of that in a pre-design effort. But we need to gain a lot more information and understanding of the possibilities, and then bring that forward to the cities and the communities and let them see what could be possibly it could become, and then refine that from there. So I don't know, Kyle or Kim, if you want to add to that.
No, Matt, you said it exactly right. I mean, as folks have seen from the conversation we're having tonight, pre-design really matters. The information that you get during a pre-design process really informs whatever project you're going to take into design. So this conversation about kind of a middle ground, is there a potential for an open water feature, as Matt just said, you would explore that. You would have the engineering ability, the landscape architecture ability to really explore that option and see what's feasible. And that is something that we're very willing to do. But, obviously we're going to be super cautious about whether that can actually happen, but it's definitely something that can be looked at during that pre-design process.
All right. And I think the one thing we haven't touched on, and I think this is probably going to be our last question for this evening, is if we could talk just a little bit about the historical aspects of the parklands, maybe the foundations of the Shaker Mills, and the other things that are in both, I'll say both Donebrook Restoration at Horseshoe Park and the Lower Shaker Lake project. If we could touch a little bit about maybe the research that's involved, what we do to mitigate anything, and what we do to protect some of the historical elements that are there.
Maybe I'll start, and then Kim can weigh in as well. So, again, to Kyle's point, the pre-design efforts, both at Horseshoe and at Lower Lake, part of those pre-design efforts, and even before we launched into pre-design, we started to assemble information and understanding of the cultural, historic, the national landmark significance of the lakes, the parklands. So we've continued to gather more information, and we incorporated that information into our pre-design effort, both for the reconstruction of Lower Lake as well as the effort at Horseshoe Park, so that we made sure that whichever direction we went appropriately addressed those resources. I will say that at Lower Lake, the position or location of the historic and cultural resources just on the downstream side or the back side of the dam between Brook Road and Coventry on the kind of the northwest corner, those resources are in a very tight space. And, that was one of our early items to consider. How could you reconstruct a Lower Lake Dam without impacting? And we were taking great pains to go through that pre-design to understand how to design and construct a dam without significant adverse impact to those resources. So all along the way, we've been considering these resources and understand all of them that are in these different park spaces. I don't know, Kim, if you want to add.
Yeah, I will add. I think that was a great summary, Matt. I think we can use an example as well of what we have done in the past. So the Dome Brook project near the Art Museum, we had also done extensive historic research there, worked through the 106 process through our Army Corps permit on that project. Nothing was identified that was anything we had to be concerned about in construction. However, during construction, we hit something that we kind of said, huh, well, what is this? And realizing it might be of historical significance, immediately contacted SHPO, right, and coordinated with them. Turns out it was an old foundation to a roque court, which was an old sport played, 100 years ago. And a piece of that is now down in a museum in Columbus to showcase that historic sport that was done in the area. So we are always very cognizant of those historic resources as we do projects, both in pre-design, doing as much research as we can, but all the way through the process and even through construction. If we find something, we stop, we investigate, we have the conversations with the right folks in order to make sure that, things are done the right way.
All right, and we're pretty much, we're out of questions from the group. So let me just open this up. For those of you who are on the webinar, please join us at our open houses tomorrow. Again, tomorrow we're at the Cleveland Heights Public Library. We're at the branch on Lee, and we will be there from 11 a.m. until 1 p.m. as well as 5 until 7 p.m. We'll have sewer district staff on hand. Some of our community partners will be out there with information about their upcoming events. And we're really here to have these detailed discussions, talk further and go from there. So thank you, John, for putting that back up. There is no registration required. There is no formal presentation. So you don't need to be there right at 11 or right at 5. You're not going to miss anything. We'll be there for you. And it's just an opportunity to look at some of the images, some of the things that Matt had in the presentation today, and ask questions if you really want to learn more about modeling or historical preservation or what the different things are. We'll have folks there from the sewer district that are there to help you. And again, let's open this up to Kyle, Matt, Kim, if anybody has any additional comments or anything that we missed today that you'd like to bring to the group. I'm happy to open the floor to you.
Matt or Kim, you want to say anything else?
Kyle, I'll also say we really appreciate the interest and the dialogue. We take great pride in trying to deliver the best solutions for flood control, stream bank erosion, and uplift of water quality to all of our stream resources in the storm water program. So we welcome the dialogue, and we'll continue that dialogue as we move forward to help folks understand the different dynamics that are involved in these challenging projects.
That's right. Kim, you want to say anything?
No, I just want to thank everyone for their interest as well. And we do enjoy reaching out, explaining, and, letting everyone know what we're doing. So we appreciate the opportunities.
That's exactly right. And I just really want to thank everybody who joined us. We appreciate you coming on this through this conversation with us. I want to thank the team of district staff that have been answering questions while the webinar has been going on. This has been quite the group effort. And again, thanks to everyone who joined us. We appreciate the interest. We're committed to continuing to answer your questions. If we didn't answer it fully, if we didn't answer it right, let us know, and we will continue to provide that information and have the conversation. So thanks, everyone.
Absolutely. Thank you. And just as a quick reminder, if you have friends, family, colleagues who didn't get a chance to see the webinar, it will be posted to neorsd.org/Lower Lake sometime tomorrow. And as well, there's also a great repository of other information, things that might help you. So we look forward to seeing you tomorrow if you're able to make it. If not, I look forward to seeing you at a future public event. Thanks so much.